Welcome to our exploration of life on Mars, where we delve into the challenges and adaptations necessary for human survival on the Red Planet. Imagine stepping onto a world painted red, a landscape both alien and eerily familiar. The allure of Mars, our celestial neighbor, has captivated humanity for centuries, but transforming this vision of settling the Red Planet into reality presents a breathtaking array of challenges. Join me, Ramesh Adhikari, as we embark on a journey to uncover the hurdles and breakthroughs awaiting us on the path to making Mars our second home. Mars, the red planet, named for its rusty hue, presents a stark contrast to our blue planet. Its surface, covered in iron oxide, gives it that distinctive red color, making it look almost otherworldly when compared to the lush greens and blues of Earth. Imagine this: you step out onto the Martian surface, and the first thing that hits you is the biting cold. It's not just any cold, it's a cold that seeps into your bones, making every movement feel like a struggle. The average temperature? A bone-chilling -80 degrees Fahrenheit. To put that into perspective, that's colder than the most frigid winter nights on Earth, where even the hardiest of creatures struggle to survive. That's colder than the coldest temperature ever recorded on Earth. And yet, this is the daily reality on Mars, a planet that seems to challenge life at every turn. And if you thought that was bad, at the poles, temperatures can plummet to a mind-numbing -200 degrees Fahrenheit. These polar regions are like the ultimate test of endurance, where only the most resilient could hope to survive. Now you might think, okay, I'll just bundle up. But it's not that simple. The cold on Mars is so intense that even the best insulation might not be enough to keep you warm. But the Martian atmosphere throws another curveball. It's not just the cold you have to worry about, it's the very air you breathe. It's about 100 times thinner than Earth's, and instead of the air we breathe, it's mostly carbon dioxide. This thin atmosphere means that the pressure is so low, your blood would boil at the surface without a pressure suit. Trying to breathe on Mars would be like trying to breathe underwater. Not a good idea. But wait, there's more. The thin atmosphere also means that it can't protect you from the sun's harmful rays. Unlike Earth, with its protective magnetic field and thick atmosphere, Mars is exposed to the full brunt of cosmic and solar radiation. This radiation is not just a minor inconvenience, it's a serious threat to any form of life. It's like having a constant barrage of tiny, invisible bullets raining down on you. Over time, this radiation can cause severe health issues, making long-term survival on Mars a daunting challenge. So, forget sunbathing on Mars. You'd need a radiation-proof shelter just to survive a Martian afternoon. These shelters would have to be meticulously designed to block out the harmful rays and provide a safe haven. We're talking underground habitats, shielded domes, basically anything to escape the relentless bombardment from space. These structures would be our lifeline, our only means of creating a habitable environment on this hostile planet. It's a hostile environment, no doubt, but that's what makes the prospect of conquering it so exhilarating. The challenges are immense, but so are the rewards. The idea of humans thriving on Mars is not just a dream, it's a testament to our ingenuity and determination. So we've established that Mars is not exactly a walk in the park. The red planet is a harsh, unforgiving environment with extreme temperatures, high radiation levels, and a thin atmosphere that offers little protection. It's a place where survival is a constant challenge. But humans are nothing if not resourceful. Our history is filled with examples of overcoming seemingly insurmountable odds, and Mars will be no different. With the right technology and ingenuity, we can turn this barren landscape into a new home. Let's talk about how we'd actually live on this unforgiving planet. The first step is designing habitats that can withstand the harsh conditions. These habitats need to be more than just shelters, they must be fully functional living spaces that support human life. Forget sprawling houses and open-air cafes. Martian homes would be a marvel of engineering and efficiency. Every inch of space would be utilized to its maximum potential with multifunctional furniture and compact living areas. Picture airtight, pressurized structures, almost like living in a submarine, but on another planet. These habitats would need to be completely sealed to keep the thin Martian atmosphere out and maintain a stable internal environment. And where would we build these futuristic dwellings? Location is crucial. We need to find areas that offer natural protection and resources. Proximity to water ice deposits, for example, would be a significant advantage. Well, going underground isn't just about escaping radiation. It also provides natural insulation against those extreme temperatures. Subsurface habitats could offer a stable environment shielded from the harsh surface conditions. We could even use Martian soil called regolith to pile on extra layers of protection. This regolith could be used in construction, providing a readily available material to build and reinforce our habitats. Of course, we'd need some serious technology to make these habitats livable. Advanced life support systems would be essential to create a sustainable environment. Think advanced life support systems to pump in oxygen, regulate temperature, and recycle every drop of water. These systems would need to be incredibly efficient and reliable, ensuring that we have everything we need to survive. And let's not forget about light. Natural sunlight on Mars is weak, and frequent dust storms can block it out entirely. With weaker sunlight and frequent dust storms blocking out the already faint sun, we'd need artificial lighting systems to mimic day and night, grow food, and basically keep us from living in perpetual darkness. These lighting systems would be crucial for maintaining our circadian rhythms and supporting plant growth for food. Now let's talk about everyone's favorite subject, food. It's not just about sustenance, it's about comfort, culture, and connection. Imagine being millions of miles away from Earth and craving your favorite dish. How do you satisfy that longing? Shipping groceries from Earth to Mars? Not exactly practical when a one-way trip takes months. The logistics alone would be a nightmare, not to mention the cost and the risk of spoilage. That's why Martian settlers will need to become experts in, well, Martian farming. They'll have to grow their own food, adapting to the unique challenges of the Martian environment. But how do you grow food in a place where nothing grows naturally? The Martian soil is dry and barren, lacking the nutrients plants need to thrive. That's where technology comes in. Advanced farming techniques and equipment will be essential to turn this red planet green. Imagine high-tech greenhouses bathed in the glow of artificial sunlight, equipped with state-of-the-art systems to monitor and control every aspect of the growing environment, where we cultivate specially engineered crops that thrive in Martian soil. These crops would be designed to withstand the harsh conditions and still provide the nutrients we need. We might even need to go full-on hydroponics, growing plants in nutrient-rich water solutions instead of soil. This method could maximize space and resources. Growing plants in nutrient-rich water solutions instead of soil. This method could maximize space and resources, making it ideal for the confined habitats on Mars. And water itself? That's liquid gold on Mars. Every drop would be precious, and finding reliable sources would be a top priority. We'd need to find ways to extract it from underground ice deposits, which could be a challenging and resource-intensive process, or maybe even capture it from the thin Martian atmosphere. Innovative technologies would be required to make this feasible, and every drop would be precious, recycled and reused with incredible efficiency. Water conservation would be a way of life. Forget long showers and leaky faucets. Martian life would be all about conservation and resourcefulness. Every action would be measured to ensure no waste. Forget long showers and leaky faucets. Martian life would be all about conservation and resourcefulness. Every action would be measured to ensure no waste. It's a good thing humans are adaptable, right? Our ability to innovate and adapt will be our greatest asset in making Mars our new home. So, what would a typical day on Mars look like? Well, for starters, forget about feeling light on your feet. Mars has about 38% of Earth's gravity, so you'd still feel weight, just less of it. Think of it like a constant low-gravity workout. Sounds fun, right? Well, maybe not. Long-term exposure to low gravity can weaken bones and muscles. That means Martian settlers would need to be disciplined about exercise, maybe even using special equipment to mimic Earth's gravity. And if you thought dealing with a delayed text message was bad, try communicating with Earth from Mars. A one-way signal can take anywhere from 13 to 24 minutes, depending on the planet's positions. That means no real-time conversations, no instant updates from home. Martian settlers would need to be incredibly self-sufficient, able to solve problems and make decisions on their own. It's a good thing humans are natural explorers, right? Living on Mars wouldn't just be a physical challenge, it would be a profound psychological and social experiment. Imagine being millions of miles away from everything and everyone you've ever known. The isolation, the confinement, the constant awareness that you're living on a planet that's trying to kill you, it would take a toll. Maintaining strong community bonds, fostering a sense of purpose, and providing psychological support would be crucial for the mental well-being of Martian settlers. And then there's the question of how Martian society would evolve. Would they develop their own customs, traditions, even their own language? Would they see themselves as humans, Martians, or something in between? These are questions we can only speculate on, but one thing's for sure. Life on Mars would be unlike anything we've ever experienced. Despite the challenges, the prospect of life on Mars is filled with incredible opportunities. Imagine being among the first humans to explore a new world, to study its geology, to search for signs of past or present life. What secrets does Mars hold, hidden beneath its red dust and ancient craters? The quest to answer these questions would drive innovation and push the boundaries of science and technology, benefiting not just Mars but Earth as well. The technologies we develop for Mars, from life support systems to renewable energy sources, could have applications here on our own planet, helping us address climate change, resource scarcity, and other pressing issues. And perhaps, just perhaps, by venturing out into the cosmos, we'll gain a new perspective on our place in the universe and the importance of protecting our pale blue dot. Thank you for joining us on this journey to Mars. We've explored the daunting challenges, the ingenious adaptations, and the tantalizing opportunities that await us on the red planet. From engineering self-sustaining habitats to cultivating Martian crops, from coping with psychological isolation to pushing the boundaries of human ingenuity, the quest to settle Mars will test our limits and redefine what it means to be human. But as we've seen, the human spirit of exploration and innovation knows no bounds. So stay tuned for more fascinating insights into the future of space exploration and human adaptation. The Martian future awaits.